Within the topic of operant conditioning, we're going to talk about today about schedules of reinforcement. But before we introduce this topic, we need to make sure that we're clear about one particular concept, and that's the concept of contingency. And the notion of contingency needs to be clear before we go into the topic of schedules of reinforcement. And an important thing is to keep in mind that the concept of contingency applies to all forms of conditioning, whether it's Pavlovian conditioning or it's instrumental operant conditioning. And just to illustrate the concept, well, first let me give you the uh, definition of contingency. It's when we talk about contingencies, we're talking about the conditions upon which specific events occur in a conditioning situation. So, if you are thinking about Pavlovian conditioning, let's say um, auto shaping, then we're talking about we can describe the contingencies of Pavlovian conditioning of auto shaping as a presentation of an 8-second light, let's say, every 60 seconds, and follow it each time, each presentation of light with food, with a single pellet of food. That's it. That's a description of a Pavlovian conditioning situation. Notice that I make no reference to the behavior of the animal. One would expect, from what we know about auto shaping, that the animal will approach eventually the light that it's being paired um, with food. But when we're asking about a contingency, we're asking about how is the light exactly paired with food. So we're saying here, well, we're presenting this 8-second light every 60 seconds, and every time the light, at the end of the light, we present a single food pellet. Relatively straightforward. And that's why it's not a major issue in Pavlovian conditioning. But when we're talking about operant conditioning, situation gets a little bit more complicated, because now we're not only talking about when things are presented, but when things are presented as a consequence of behavior. Think about the possible things that could have varied in the Pavlovian conditioning situation. Not that many. We can present different CSs, so different lights or different stimuli, or different USs, different, food pellet, or it could be a shock, it could be aversive, and the timing of these events is what's critical in Pavlovian conditioning, right? How often do we present them, for how long is it presented, so on. But think about now operant conditioning. In operant conditioning, now we have, on top of all of this, we have the fact that some of these events are dependent on the behavior of the animal, and how dependent they are upon what kind of behavior are they dependent. That's what we need to specify when we're talking about the contingencies of operant conditioning, and we often refer to them as the schedule of reinforcement. All right. So that's what we mean by schedule of reinforcement. Now, if you think of it, there's virtually an infinite numbers of ways in which you could arrange reinforcement for an instrumental reinforcement for an organism. But to keep things manageable, we've consider what are the different things upon which, the different variables upon which reinforcement could be dependent on. So let's focus now on schedules of reinforcement. We'll focus on what could reinforcement be dependent on. And in general, we can think about two main things that that reinforcement could be dependent on. It could be dependent on the behavior of the animal, or it could be dependent on the passage of time. right? So we can say, well, schedule maybe yes, dependent on behavior, or no, independent of behavior. It could be yes, dependent on time, or no, independent of time, of the passage of time. This gives us a matrix, right? Where if we have a schedule where reinforcement is dependent on the behavior of the animal and on the passage of time, we're talking about, we call these schedules interval schedules. If they are dependent on the behavior of the animal, but they're not dependent of the passage of time, we call these ratio schedules. And if they are dependent on time, but not on behavior, we call those time behaviors. So, just to give you an idea, oh, well, and what happens if it's not dependent on time or on behavior? Well, then reinforcement, it has to be dependent on one of the other. So we're not even going to consider this possibility. Right? We have to identify what is reinforcement dependent on, and we identify time and behavior if possible. You know, variables that control reinforcement, and so we will need a third one to fill up this particular cell. In any case, let's think about a couple of examples about interval, ratio, and time schedules. So for interval schedules, we say that it is dependent on behavior and it's dependent on time. So think about when you're baking something, you're cooking something, right? You put it in the oven. It requires some behavior. You need to put things in the oven, but you need to wait 15-20 minutes for things to cook. There's nothing you can do to speed up the process in general, right? The so cooking, you know, cooking, baking, that kind of behavior requires the environment to take its own course, takes its own time to finish its own things, but also requires behavior because you need to put things in the oven, you need to remove things from the oven after a certain period of time. If you if you put water to boil, then to get the boiling water, you need to do certain things, but then you have to wait, and and there's nothing you can do to make water boil faster once you have the right temperature. Contrast that against a ratio schedule. In a ratio schedule, the now reinforcement is completely dependent on behavior. So when when you're biking to a particular place, or you're walking to a particular place, how fast you get there to the place that you're going to, well, depends on how fast you walk. It doesn't depend on anything else. It depends on how fast you ride your bike. So you need to complete certain behaviors. The faster you complete them, the quicker reinforcement occurs. All right. So that's the rule of thumb for thinking about ratio schedules. The more you do, the more you get. With interval schedules, not necessarily. You can do a lot, but you also have to wait some time. It's reinforcement is contingent upon time too. Now, when it's only a time schedule, when there is no behavior that is that can produce that, when reinforcement is not dependent on behavior at all, uh, then we refer to this as time schedules. And you can think, for instance, about getting your mail. You're waiting for a letter, and that letter, to the extent that there's nothing you can do to make that letter arrive, you just have to wait. It will eventually arrive. Then that is a time schedule. There's nothing you need to do in that situation. So we often refer to these time schedules as reinforcement arranged in time schedules as non-contingent reinforcement. All right, non-contingent reinforcement. So we're not going to focus that much on this, because this involves reinforcement that is not contingent on behavior. So let's take that out. We're not going to focus too much on that. We're going to focus instead on the main two categories um, of schedules of reinforcement: interval and ratio. So to put it in a little bit more abstract terms, more general terms, let's put it that way. Think of an interval schedule. Think about two animals responding on an interval schedule, and you're reinforcing a response. Let's say lever pressing, and this is time moving to the right, and so we are representing this as events on time, and we're saying that let's say this is an uh, fixed interval. We're going to talk about what the fixed part means, but let's call this it's an interval schedule, and we refer to it as a fixed interval schedule 1 minute. All right. So what this means is that the first response after 1 minute has passed is going to be reinforced. So this is where the timer starts. Typically, the timer started by the previous reinforcer. And now I'm going to represent behavior with ticks. So these are lever presses. Suppose this animal is pressing a lever like this. Oh, let's suppose that this corresponds to 1 minute. So the first response after this time, it's supposed to be a straight line, after this time is going to be reinforced. So you may have an animal that responds at this rate, and this one, the one right after the 1 minute has lapsed, this is reinforced. You can have another animal that actually responds very slowly, and it gets reinforcement at the same time. So notice that in an interval schedule, an animal can respond really fast or really slow, and either way, the animal will get reinforcement only after the 1 minute, but it has to make a response. All right. Now think about now let's illustrate a ratio schedule. And we're going to call this a fixed ratio. As I said before, I'm going to explain in a little bit what I mean by the fixed part of the schedule. Fixed ratio 5. So now we're specifying how many responses the animal has to produce to obtain reinforcement. So here's where our clock starts. And so you may have, again, one animal that responds really fast. 1, 2, 3, 4, 5. This one is reinforced, the fifth response. You may have another animal that responds really slow. 1, 2, 3, 4, 5. Oh. And this one is the response that is going to be reinforced. So notice the difference between ratio and interval schedules. In the interval schedule, it doesn't matter how fast the animal responds, as long as it responds a little bit. Right? Reinforcement is arranged about once per minute in this example. In the ratio schedule, reinforcement depends completely on how fast the animal responds. So if the animal responds really fast, reinforcement comes very fast. If responding is very slow, reinforcement is delivered slowly. All right. So to represent this, we use what it's called feedback functions. So let me erase this part so I have a little bit of space. And so what we're going to do is we're going to draw the feedback function for feedback functions. And what the feedback function for an interval schedule, what the feedback function is a description of the schedule in terms of how rate of reinforcement, I'm going to refer that to R plus, is this is reinforcement, rate of reinforcement is related to response rate. So what happens when you respond faster? What happens when you respond slowly? And as you can imagine, in the case of the interval schedule, if in this example in particular, if this is once per minute, the rate of reinforcement, that's as fast as you can get. And in fact, it only takes a little bit of responding to reach that asymptote. But regardless, after a little bit of responding, regardless of how fast you respond, rate of reinforcement is topped at once per minute, or whatever the schedule may be. So, as an experimenter, as a person arranging the rate of reinforcement, as a person arranging the schedule of reinforcement, you have full control over, almost full control, with the exception of this little curve here. You need to get the animal to respond a little bit, but for the most part, you have, as the person who arranges the schedule of reinforcement, you have control over the rate of reinforcement. So different schedules of reinforcement here may look like this, right? Now, think about what happens in a ratio schedule. Again, this is rate of reinforcement. This is response rate. And now, the feedback function looks very different, right? For if the faster I respond, the faster, the faster I get, the quicker I get reinforcement. Rate of reinforcement, of course, both rate of reinforcement, of course, is represented in reinforcers. Oh, reinforcers per minute or per second, per unit of time, and the response rate is in responses per unit of time. In this case, this could be minutes. Okay, so the more responses per minute I produce in a ratio schedule, the more reinforcers per minute I obtain from that schedule. That's the nature of a ratio schedule. And the different schedules may be represented with different slopes of this curve. That's a critical difference between interval schedules and ratio schedules, right? And notice one thing that's really important, that the feedback functions and the schedule itself do not say anything about how the animal should respond or how the animal will respond to the schedule. It just describes how the environment is arranged. The environment can be arranged this way, the environment could be arranged this way, the environment could be arranged as a time schedule, but we're not discussing that here. So there is no description about how the animal is behaving here or here. But if you recall from the discussion about the response deprivation hypothesis, hopefully these lines here will seem familiar. This is how this is a description of how the environment may be constrained for an animal, but it could also be constrained this way. All right. Let me now erase this. Oh, sorry. And talk about more specific schedules of reinforcement. All right. So let's erase this too. We said the schedule could be interval or ratio, and well, we also said that we described the schedule as being a fixed schedule, and it can also be a variable schedule. What do I mean by fixed and variable? In the example that I described, the the they were both fixed schedules because reinforcement was contingent upon the completion of a fixed the first response after the completion of a fixed interval. The example was 1 minute, or a fixed ratio, 5 responses in the example that I used. We're going to represent this as by the initials fixed interval, fixed ratio, Fi and Fr. Familiarize yourself with these acronyms. They're going to come handy when we start discussing schedules of reinforcement in class. Fi and Fr stands for fixed interval, fixed ratio. So in my example, for instance, of the water boiling, usually water takes a fixed amount of time to boil, and at a particular temperature. So um, it may take, let's say, 3 minutes. It doesn't matter how often you check the pot if to see if the water has boiled. You have to check it after 3 minutes to see water boiling. And it's always 3 minutes, assuming that the environment is constant, that nothing changes. Um, the ratio, same thing, but not same thing. The fixed ratio involves a fixed number of responses. The example that I gave you was fixed 5 lever presses. The animal in our example had to make 5 lever presses. And oftentimes, when you have to complete something, you need to make a fixed number of responses. When you're building an IKEA furniture, there's a fixed number of responses you need to complete to get the piece of furniture completed. There's no variability to the extent that you always try to build the same piece of furniture. But there's there are these other schedules that are called the variable interval and variable ratio schedules. This is when the criterion for reinforcement varies from time to time, from trial to trial. So some things on average may take 3 minutes, but sometimes may take 1 minute, sometimes may take 8 minutes, sometimes may take 6 minutes. Think about, for instance, how often you get email, right? To read email, assuming that the email is reinforcing, um, you need to check your email, but you cannot. There's nothing you can do to make your email come faster, right? Email comes at the rate that it's sent to you. But you need to check it once in a while to see that you got email. And it doesn't come at a fixed interval. It doesn't come every 3 minutes. Sometimes you get a lot of email right one after the other, and sometimes you can maybe days in between emails. So that the variable nature of of reinforcement in that situation is represented by a variable interval schedule and a variable ratio schedule. A variable ratio schedule is when you don't have to complete a fixed number of responses to obtain reinforcement, but rather the number of responses is varies from trial to trial. So think about, for instance, a slot machine. That's a typical example of a variable ratio schedule. Slot machine, every time you make a response, you have to complete a number of responses to win a reward, to get some money back, to win a prize, right? But you don't know how many responses you have to make. It may be that the next one, the next response, the next pull of the one-armed bandit is going to give you the money. Or it could be that it may take you 5 or 10 or 15 or 100. You don't know. But on average, you know, there's a number of responses on average that will give you a particular payoff. All right. So it's very important that you distinguish between fixed interval, fixed ratio, variable interval, variable ratio schedules, and also to keep in mind what is the typical outcome of this schedule. So I'm going to try to draw it here. Now our dependent measure is rate of responding, and this is time in the schedule. And oh, sorry, it's not rate of responding. Typically, the way that we represent the effects of schedules in on behavior is through cumulative records. So this is the cumulative number of responses. So it has to go up because cumulative over time on a particular schedule. And so, as you may imagine, now we're talking about what behavior we expect the animal to show. We know this because we've run over many years. Many experiments have been conducted on these different schedules, and we have an idea about what kind of behavior they produce. So up to now, everything that I was describing was about the arrangement of the environment. Now I'm going to talk about how that arrangement typically affects behavior. And so when we're talking about a fixed interval schedule, I'm going to go fixed interval, fixed interval, fixed ratio, variable ratio. What you typically see with a fixed interval schedule is this kind of scalloped pattern, right? Where this is your interval. Think of it, it kind of makes sense. This flat line indicates that there is very little responding. Responding is not accumulating, and it accumulates really fast, close to the end of the interval. To the extent that you are sensitive to the passage of time, and that you have learned that there's nothing you can do to make reinforcement happen sooner, it makes sense that you would make most of your responses close to the end of the interval than at the beginning of the interval. And this is what most animals do, right? Now, with a fixed ratio schedule, what you typically see is a pause followed by a ramp of responding. Something sort of like this. We often refer to this pause as the post reinforcement pause, or PRP. So think about when you have to complete, if you had to complete several IKEA furnitures, that each of them requires a number of responses, a fixed number of responses. What you would typically see is that you make this burst of responses, and then you get, and reinforcement is delivered here, complete the furniture, and then you take a pause, you take a break before you start the next one, and then you go really quick, finish it, get reinforcement, and then a pause, and then real quick, next one, and so on. And those pauses we refer to those as post-reinforcement pauses or pre-ratio pauses. They go by both names. Both of them have the same acronym, PRP. Okay. Now let's talk about variable intervals, variable schedules, and particularly a variable interval schedule. All right. In the variable interval schedule, the passage of time determines when a response is going to be reinforced, but there's nothing indicating how much time you would need to wait to make the next response. So intuitively, you can imagine that most animals, what they do is they respond at a relatively, low rate, but a steady low rate, and there are very little pauses because any response at any time, the interval might have elapsed and the next response would be reinforced. Variable interval. So this is like your email checking behavior. We check it every so often at a low rate, just to make sure that, just to collect those emails that have been accumulating or that have been delivered to us. Now, on a variable ratio schedule, you typically see also a steady rate of responding, but at a higher rate. The animals typically respond faster on a variable ratio. Because if you think of it, any response could be on a variable ratio schedule. Typically, any response could be the one that is going to be reinforced. Maybe it's the next one, maybe it's the next one. And if this wasn't the one that was reinforced, well, maybe the next one is the one that is reinforced. Like in a slot machine. And this is why slot machines are so effective at maintaining behavior. And variable ratio schedules are very effective at maintaining behavior. Alright, well, this concludes our section on schedules of reinforcement.